Hi, welcome to Modern Analytic Academy Vignettes. My name is Armando Marrero. I'm a senior partner solution architect with American GPS Group and Microsoft. Analytic vignettes regularly address new features and how to use them, frequent questions we receive, and updates to a previous section. Today section is going to be about building a near real-time warehouse in Microsoft Fabric. Academy section falls under five pillars. Today's section is going to be touching four of those: acquisition and storage, modeling, pipelines, and visualization. The first thing that we're going to explain is why we should use or put together a dimensional model. Here are a few of the benefits, starting by performance optimization. Star Schema simplify the query logic, which can significantly improve the performance of Power BI report. By having a central fact table surrounded by dimension tables, the database engine can quickly scan and aggregate large volume of data, leading to faster query response times. Easier use. Star Schema is easier to understand and navigate, making it more user-friendly for report developers and business users. Users can easily relate the fact table, which hold transactional or quantitative data, with the dimension tables, which contain descriptive attributes, simplifying the data exploration and reporting process. Their integrity and quality. In a star schema, that integrity is enforced through the use of keys and relationships. This ensures the data in the fact table correctly aligns with the dimensions, leading to accurate and reliable report. Scalability. Star schemas are highly scalable. As the volume of data grows, the simplicity of the star schema allows for easier management and expansion without significantly impacting performance. Efficient data refresh. Power BI's data refresh process can be more efficient with star schema. Since the schema is logically organized, refreshing can be optimized to only target specific tables as needed, rather than processing the entire dataset. DAX formula simplicity. The clear distinction between measures in the fact tables and attributes in the dimension tables makes DAX formula simple and more intuitive. Better support for time intelligent function. Time intelligence is a crucial aspect of business analytics. Star schemas typically include a dedicated day dimension, which enhances the ability of Power BI to perform complex time-based calculation and comparison. And lastly, facilitate historical data analysis. With dimension tables, it's easier to handle slow changing dimensions, which are crucial for historical data analysis. This allows users to track how data evolves over time. In summary, using a star schema in Power BI helped in achieving better performance, easier use, data integrity, and overall more efficient and effective data modeling and reporting. Without further delay, let's jump into the demo. Okay, what you see now in the screen is the user interface for Microsoft Fabric. Under Microsoft Fabric, you can create multiple items like data warehouse, layhouses, reports, semantic models, and many others. I already created one workspace, and inside the workspace, I created this Fabric warehouse, which is the centerpiece to put together all the components that we're going to be discussing in this demo. First, which we were going to start by putting together, creating tables that we will need to store the data that we're going to be ingesting. The first table that we're going to create is stock prices. This table, we're going to have the symbol that represents the stock, the timestamp of the price that we're ingesting, and the actual price, and also a day stamp, which is a simple transformation from the timestamp to only contain the date. That is done to facilitate further transformation down the road. these schemas, we are trying to organize the schema a little bit. So because this table specifically is storing temporary data, we are putting it in a schema that we call as STG, that meaning is staying. We also create another schema to represent the ETL, which is stand for extract, transform, and load. And the idea is to put together all the components related to our data ingestion, data transformation process into that schema to better organize the objects. The first table that we're creating is ingest source info, which is no more than a table to maintain track of the latest value of the timestamp that we ingested in order to provide incremental updates instead of full loading the data every time that we run the ingestion process. We start by inserting one record into the table that represents the stock prices, and we put a date, which is the beginning. At this time, it's like 2 years ago. And then we are also setting the flag, active flag, to yes, in order to be able to process it. This is the first scene. This is the first data structure that we created to proceed. The second thing that we are going to do is navigating to the data pipeline that we put together to get that data ingested into the Fabric warehouse. This data pipeline contains multiple activities, starting by a lookup that we call it get watermark. The watermark is in the specific lookup. What we're doing is we are providing a query that is querying the table that I just showed you in order to bring any record in the ETL ingest source info that is actually active. At this time, in this demo, it's only one record, but it could be more. And actually, in real life scenario, you're going to be putting more columns into that table, like query source, parameters, and audited information, and many others. But because this is a demo, we scope it down to represent, to only showcase what is actually the core piece of the data ingestion when you're using a data-driven architecture. So once this step get executed, then you're gonna get a bunch of items that represent any record in this table that is currently active for data ingestion. Then we proceed with a for each activity in order to loop through those records, and then for each one we're going to be the first activity that we're going to be putting together is a copy activity. The source in this case for that copy activity, as I mentioned before, we're bringing data from a top prices data from a QQL DB. It's been updated and it's actually part of another vignette that we have here in the Modern Analytic Academics. So the query that we are going to be using to query the QQL database is a very simple one. We are just querying the stock tables, and we are filtering the timestamp for any day that is greater or equal to the watermark that we're maintaining in the table, in the stock info table, ETL info table. Then we bring additional column like the day stamp. This is the transformation that I was mentioning before. We also get the symbol, the timestamp, and the price, and we are restricting the records to 500,000 and excluding any record that had a null price. Once we have this, this is the source. So when we execute this source component, it's gonna be connecting to the QQL database and bringing over all any record that match the criteria that we had on the query. And you saw here, you can put a table, but if you want to be more flexible, like we needed in this demo, then you go with a query. The destination is going to be the stock prices table that I showed you before in the STG schema. Basically, the table represents the latest ingestion from the KQL database. And as I mentioned, it is a temporary table, so it only contains data that present the latest process, but it actually get deleted before we date it. In order to accomplish that, we're using a pre-copy script. We delete the table before we actually reload during this process. Once the data is copied over, then the next step that we're going to follow is to get the new watermark from the stock tables. And this is the query that we're using for the to get the watermark from item object name at this time to represent the table, in this case stock prices, because this is the only one that we have on the table. So we are selecting the max timestamp as watermark from that table in order to get the new watermark. Then we have to date the table that store the watermarks, and for that purpose we had a store procedure that I'm going to show you after this, with a set two parameters: object name and the new watermark that you're gonna be storing. In this scenario, we're getting the watermark that was processed on the previous activity. The previous activities get new watermark, and then output first row, because there is only one row in that table, and then the watermark. That's the other parameter. Before continuing on this pipeline, let's go back to the warehouse to show this ingest source info update stock procedure. Okay, we're here. Okay, here is the stock procedure that update the ingest source info. It's very simple. It takes two parameters, object name and watermark, and only execute an update statement, filtering by the object name and setting the watermark with the parameters that have been passing through. Once that happens, we will need to do additional things. We're putting together a small star schema that contains 2 dimensions and 1 file table. The first thing that we're going to be talking about in this one is the date dimension. The date dimension is a very important component. Before I actually show how we populate that table, let's quickly show here how the table actually looked. Was the day dimensions are critical in any data analysis or data warehouse solution, in order to create analytics report and do time intelligent analysis or time traveling, in order to compare different periods, aggregate data at multiple levels across time. So for that purpose, you regularly create a date dimension. In this case, this is a very simple one. It only contains 4 columns. Or the first column is the day key, which is actually a date for each day in the period that we are populating here, and then a few additional columns just to showcase how it is put together. So how did we put this day dimension together? Is for that thing we created this stock procedure, which is it's a very simple one. We only run one time because the day dimension, once it is populated, we don't need to refresh it any longer in this specific demo. So we are accepting 2 parameters, begin day and end day, and we're setting the default values to September 01, 2023 and December 31, 2023. We declare a number of days variable that contain the difference, the days different between those 2 days. And then we loop over those numbers of days using a while. And for each day that we get into that loop, then we insert a record in this date and put it together, day key, and the other 3 additional columns are derived from the day key. As you see here, we are adding the number of days, we're decreasing the number of days in order to eventually get out of the loop. So this is stock procedure. We execute only one time because this is a static dimension. Second dimension that we need for this star schema is DIN symbol that actually represent the stocks itself. For each stock that we are going to be bringing over, we had a symbol that represents the stocks, we had a name, and we had a market, which is no other than NASDAQ, SP500, and DOG. This is it is only a sample of data, so that we can explain how a star schema around these the stock prices and showcase the sample. How do we update this table? First, one of the difference between the DIN symbol and DIN date is DIN symbol is not static. So what I mean is it has to be updated every time that we bring over a new data set from the QQL database. Why? Because eventually we could be bringing over new stock symbols or new stocks data that we didn't have previously here. And then if that's the case, then we have to add it here. If no, then it's already there. Just keep it the way it is. How do we accomplish that? Then this is the stock procedure that handled that process. So basically, we have to maintain a surrogate key. In order to do that, we first query the data, the existing data in DIN symbol. We get the surrogate key from that table, and then we add one in case of to eliminate nulls. Nulls, in case of null, we put 0, and only we add 1 because we don't want duplicates. Then we are using row number to get the values for any record, plus the max value that we already calculated. We get the symbol. Stock is a market are functions that kind of transform a little bit the symbol, and then we get everything in this stock procedure is doing a select distinct from this view that I'm going to show you after this. This view is very close to the actual stock prices table that I showed you before, but I'm gonna go over that view after this. So that's the source for the query, and then we use distinct because we are only needed. We're trying to identify stocks here that are new or existing, and then in order to get only the new ones, then we use this word criteria here, where we say where the symbol is not already in the symbol. Okay, before we move forward, let's show how this actually this symbol DIN date. This is the SQL to create the DIN date that we discussed before, and this is the DIN symbol create table statement, which contain the surrogate key for the symbol, as I explained it before on the stock procedure. How do we populate it? The symbol, the name, and the market. And we also created a fact table that we are going to be using to store the actual stock daily prices. This fact table contains a surrogate key, the symbol SK, which is a foreign key to the DIN symbol table, the DIN symbol dimension, and the price day key is also a foreign key to the day dimension. And the specific metrics that we're gonna be saving here is minimum price, max price, and close price. And you see here, this table that has a cardinality of it's a daily cardinality, so we have one record per stock per day, and for each record we maintain three metrics: minimum price, max price, and close price. So now let's go back to the stock procedure that we were let's go back to the pipeline. As I mentioned before, we had to execute that pipeline that stock procedure to the DIN symbol, the symbol dimension every time that we ingest data. So in order to accomplish that, we add another activity after we get out of the ingest for each. And then we are calling that stock procedure that we just created. Stock procedure is doesn't have any parameters, and then here we are specifying, hey, this is the stock procedure that we need to execute here. Remember, when we get to that step, the data is already ingested and the data is already in the stock prices table. But as you remember, let's go back to the stock procedure. We are using in that stock procedure, we are accessing a view. So let's go back to the view to see what the view is doing. Okay, views, where are the views? Let's say this one here. Okay, so this is the view that we're using there. Is reading data from stock prices, which is the temporality table or the staging table that contain the latest data ingestion from the KQL database. We group that table by symbol and date, and then we calculate the minimum, the maximum, and the close price. As I mentioned before, these are the three components that we need. And then we use that in order to not only to determine what are the symbols that we are bringing over, but also to date the fact table that you will see later down the road. This another view here is actually the one that we're using for the fact table because it already have the join to the date dimension and to this symbol dimension to facilitate the data set, the source data set for the fact table. And you see here, we're bringing the surrogate key from the symbol dimension, and then the surrogate key, the other key from the date dimension over here, date dimension, the D, and we are renaming it to match the column on the fact table. Then mean price, max price, and close price. So now the last step that we will need to put together is a stock procedure to date the fact table. Let's go now to show that stock procedure. This is not necessarily the only way to accomplish this process, but at this time at Microsoft Fabric, we don't have a merge statement. So we come out with this another alternative solution, which is based on CTAS statements in Microsoft Fabric, which is create table as selects. And we are creating a new table based off the existing data on the fact table in order to save it. After that, we delete the actual fact table, and then we recreate it again using the create table as. This is a high performance way to create tables, parallelizing as much as possible. In order to do that, then we read from the view that I just explained that already contain the joins to the dimensions, and then this view at this time represent the new data, the data that we're trying to add to the fact table. So before we add it, we had to validate some stuff, and not only that, we had to join with the existing data. The existing data is on this table. That was the first one that we created here from the currently existing data in fact stock daily prices. We join by the symbol surrogate key and by price day key, all versus new. And then what we do here, we put together some sort of logic to derive the surrogate key for the fact table, trying to derive to get the symbol escape, because this is a full outer join. Eventually, either the new symbol escape or the old symbol escape could be null. That's the because of that we had to put this logic here. Same situation will happen with the price day key, and then on the minimum price we put some formula to determine which one is the right value to put or to get on the fact table, depending on in the minimum price. Then we say if the new one is null, then take the old one. If the old one is null, then take the new one. Else, then we compare minimum price, new minimum price versus old minimum price. And if that's the case, then we get minimum price. Else, we maintain the old one. We cannot do the same thing on max price and on the close price. Very similar. Once this create table as statement is done, then the new fact table is already recreated with the adding the new data, and then we drop the first object that we created initially, kind of cloning the existing fact table at that time. Everything had to be put together in a transaction because if something failed, we had to roll back the whole step, every step that we had done during this process to maintain data integrity. Once this step procedure is done, then we have to execute it in our pipeline. In order to do that, we add another step procedure activity at the end of the pipeline that is doing no other than calling that step procedure that I show you. The step procedure is not setting any parameters, and that's pretty much what this pipeline is going to be executing. In order to get to a near real-time uh, solution or data ingestion, you have to schedule the pipeline with as close as possible to real time. I tried this with running every 5 minutes, and it worked perfectly fine. You can do it maybe every 1 minute, every 3 minutes, as long as the duration of the pipeline doesn't overpass the schedule time. You should be fine. And I think view rule history, we have some rule here that we have been running on the past. In this scenario, the latest one that we did was every 15 minutes, but we also did previously every 5 minutes. You want to go into more detail with the room history, you go to the monitoring hub and you get more information about every single run that you did. But also you can filter, you can do other things here, including that you can see when something failed. You can get details. You can retry it. So no, those are another thing that you can do once you are on the monitoring hub. This pretty much complete the ingestion process. So the second phase after the ingestion process is done, you need to put together a semantic model in order to create report out of that. The warehouse interface contain three different sort of tabs at the bottom. The first one that we were focused before was data. Query data is this one here. With navigate through your tables, different objects. Query is the other one that I was showing before, when you create queries or store procedures, things like that. And then model, it represents the semantic model. This is the place where you put together the relationship between the different tables. You actually can do other things like hiding a specific attribute that you don't want to be visible during the when you're going to be on Power BI or any other client tool. This is very important because you don't want kind of technical things to be visible. You will try to be more user friendly, specifically helping the business user to easier understand your model in order to create reports. The other thing that you see here is the relationship between the table. Once you click the relationship, you see the columns in each table is getting highlighted, and also the symbol itself is telling you what kind of relationship happened between the dimension and the fact table. This one here is one to many, one on one entry, one record in the dimension could be associated to multiples of many records on the fact table, and the same happen with the symbol, which is one stock symbol in the symbol dimension could be as many times as needed or existing in the fact table. The other thing that you see here is the metrics that I showed you before, and by default is putting some sort of default aggregation on those, even though that you can change it. You can actually hide the entire table if you want using this component here, and you can create hierarchies for each in each table that you need. In my case, because I wanted to rename this column here to make it more user friendly, I hide all these columns, and I actually create a dates hierarchy and add it back here, but rename it with a more user friendly names for easier analysis. Once you have this model created, actually, I'm going to show you that we have many other tables here, but every of those tables is actually hidden because they are not important. They are not needed for the report that we're going to be creating. We are only focused on the star schema that represent our data. Um, Once the component or the semantic model is created, then you can create reports. You select new report here, and from there you can you're gonna be navigating to Power BI in order to create your report. I'm gonna show here. Okay, this is the interface, the black canvas when you haven't created a report, and you see here, you see the date only with the hierarchy that I created, the symbol only with the attribute that I kept visible, and the same situation with the fact table with only and showing only the metrics that are needed. So now let's close this tab and let's go back here because I already have one report that I'm gonna show representing the stock prices. You can filter here to find the factor. It's going here. Okay, so let's open it, and this is a very simple one just to showcase how we can create that report from the semantic model. We put together here two graphics or two charts, one to represent the max price per date and stock and the minimum price. And also we added two slicers for one to select specific markets if you want. Let's click it here. Let's click this one here to remove all the filtering. If I would like to see only, let's say, Nasdaq, then you see it actually change, and you only see here a symbol that are associated to Nasdaq. If I wanna go with specifics, then that's another way to do it. It's a very simple report just to showcase the topic, and you click on edit, then you one more time you get your data, you get your data panel, and then you see the same thing that I showed you before when the report was initially blank. You see here it actually shows the attributes or metrics that are existing on your report or on your component in the report. Okay, so this is the final result. This report, if you wanna keep it updated, then in Power BI you can in the report you can actually update the refresh time to be more consistent with whatever the data, whenever the data is being refreshed, like every 5 minutes, every 15 minutes, whatever the case is. So the report could be maintaining updated, synchronized with the data refresh. This pretty much complete this demo. I hope you enjoy the content as much as I did, and then let's put together some additional content in the near future. Thank you for watching.